Trigonometry is the study of relationships among the angles and sides of a right triangle. A trigonometric ratio compares the side lengths of a right triangle. A trigonometric function has a rule given by a trig ratio. In trigonometry, we often use the Greek letter theta, that looks like a zero with a little line through it, to represent the measure of an acute angle in a right triangle. The hypotenuse, the leg opposite theta, and the leg adjacent to theta are used to describe the 6 trigonometric functions. So over here in the illustration, looking at angle theta right there, which is next to angle B, which is angle B, the side, the leg opposite of that is considered to be the opposite leg. And then there's a leg that is touching the angle that is named theta. We call that the adjacent leg. And then the hypotenuse is the angle that is opposite the right angle. It is always the longest side in a right triangle. And the whole basis of trigonometry is around the Pythagorean Theorem. And recall that the Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the lengths of legs and c is the hypotenuse. So knowing that we have 3 types of sides in a right triangle, we have opposite leg, adjacent leg, and hypotenuse, we have the 6 trig functions that are used in right triangles. Sine is the opposite over hypotenuse. Cosine is the adjacent leg over hypotenuse. Tangent is the opposite leg over adjacent leg. And then there, I'll work up, we have cotangent is adjacent leg over opposite leg. Secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. You can pause the video to write all these down. These 6 trig functions should be memorized. So one way to use trig functions in this example is if we're trying to figure out the sine of theta. So knowing where theta is in the picture, sine is the opposite leg over the hypotenuse. So the opposite of the theta is 4. And then the hypotenuse is the 5. So we could say the sine of theta is opposite over hypotenuse, which would be 4/5. We can also do like the cosine of theta. So the formula for cosine is adjacent over hypotenuse. The adjacent leg is 3 and the hypotenuse is 5. So the cosine of theta would be 3/5 or 3/5. And then you can do the tangent, cosecant, secant, all doing the same way. Notice that we can find the values of 6 trig functions in any right triangle. So here's a new right triangle, and we're going to use our 6 trig formulas to figure out the sine, cosine, tangent, cosecant, secant, cotangent of angle theta in this triangle. So comparing angle theta to the other 3 sides, the 8 is considered to be the opposite side, the 15 is the adjacent leg, and 17 is the hypotenuse. So to find the sine of theta, the formula for sine is opposite leg over hypotenuse. The opposite leg is 8, and the hypotenuse is 17. So we could say the sine of theta is 8/17. Cosine of theta, formula for cosine is adjacent over hypotenuse. So the adjacent leg is 15, and the hypotenuse is still 17. So we would say it's 15/17. Tangent of theta, formula for tangent is opposite over adjacent. So the opposite leg is 8, and the adjacent is 15, so it's 8/15. Then we have cotangent of theta, and I'm going to do it in the same order that they have it up there, which is why I'm going to work bottom up now. Formula for cotangent is adjacent over opposite. So the adjacent side is 15, and the opposite is 8. Formula for secant is hypotenuse over adjacent. So the hypotenuse is 17, and the adjacent is 15. And then for cosecant, abbreviated CSC, cosecant of theta, the hypotenuse is still 17, but this time we use the opposite, and that is 8. So there are the 6 trig functions for angle theta. Notice that some of the trig functions are the reciprocal of other trig functions. Notice that tangent and cotangent are reciprocal functions because tangent is 8/15, cotangent is 15/8, which makes sense because their formulas are reciprocals. Cosine and secant are reciprocals of each other. Sine and cosecant are reciprocals of each other. So another way to find a reciprocal is to take 1 divided by the sine, the cosine, and the tangent. Example 2 is fairly similar to example number 1. This time it tells us the sine of b equals 5/8, and we got to figure out the other 5 trig functions for b. So let's draw a picture from this. So I'll call this angle B down here. I'll call this my right angle. And this says that the sine of B is 5/8. Well, the formula for sine is opposite over hypotenuse. So if the sine of angle B is 5/8, that means the opposite side must have length of 5, and the hypotenuse has a length of 8. To find the cosine of B, the formula for cosine is adjacent over hypotenuse, but notice that we don't know the adjacent side right here. We have no idea what that adjacent side is until we use the Pythagorean Theorem to figure out the adjacent side. So we do our Pythagorean Theorem, and we're trying to figure out the adjacent side, so I'll just use a for that. A squared plus b is the 5 because that is the known leg, and c is the hypotenuse, which is 8. So that'll give me a squared plus 25 equals 64. Subtract 25. So a squared equals 39. And then we would finish that up with a square root. And I'm going to leave it in square root form, and I'm not going to go to a calculator. I'm just going to say a equals the square root of 39. The square root of 39 cannot be simplified, so this side is the square root of 39. So for the cosine of b, we're going to do the adjacent side over hypotenuse. So the adjacent length is what we just figured out as the square root of 39. The hypotenuse is 8. Tangent of b. So the tangent of b, the formula for tangent is opposite over adjacent. So the opposite side is 5, and the adjacent side is the square root of 39, except we shouldn't leave a square root on the bottom of a fraction, so we need to rationalize the denominator by taking it times the square root of 39 over the square root of 39, which means rationalize the tangent of b is 5 times the square root of 39 over 39. Cotangent of b, so the cotangent is adjacent over opposite. So the adjacent is the square root of 39, and the opposite is 8. And so we don't need to rationalize the denominator on that. And then we have the secant of b. So the formula for secant is hypotenuse over adjacent. So that would be 8 over the square root of 39. That would be another number that we have to rationalize. So take it times the square root of 39 over the square root of 39. So that'll be 8 square root of 39 over 39. And then I'll squeeze in cosecant here. Cosecant is hypotenuse over opposite. Hypotenuse is still 8. The opposite is 5. So that's 8/5, and we're done with that one. Over here on the side where it says study tip, this is a common way to remember the formulas for sine, cosine, and tangent using SOHCAHTOA. SO is SOH, and that means that the sine is the opposite over hypotenuse. The CAH means cosine is adjacent over hypotenuse. And TOA means the tangent is opposite over adjacent. Just a common mnemonic device for remembering sine, cosine, and tangent. And then you would reverse those for cotangent, secant, and cosecant. Angles that measure 30, 45, and 60 degrees occur frequently in trigonometry. That gives rise to special triangles. In a right triangle, since all the trig functions have the same measure, the trig functions of 30-degree angles, 45-degree angles, 60-degree angles have the same measure, we have these special triangles that can be used to figure out the exact measurements instead of decimal estimates. So the first triangle is just referred to as a 30, 60, 90 triangle because it has a 30-degree angle, a 60-degree angle, and a 90-degree angle. So the short side, which would be the side opposite of 30 degrees, has a measure of 1 right here, a measure of 1. The longer leg, which is opposite the 60-degree angle and adjacent to the 30-degree angle, has a measure of the square root of 3. And then the hypotenuse has a measure of 2. Knowing that, you can figure out the three main trig functions, sine, cosine, and tangent, by finding the sine of 30 would be the opposite, which is 1, over the hypotenuse is 2. So we would say the sine of 30 is exactly 1/2. The cosine of 30 would be the adjacent over hypotenuse, so that would be exactly the square root of 3 divided by 2. And the tangent of 30 says it's the square root of 3 divided by 3, even though I don't see a whole number 3 there. But the reason for that is because the tangent formula is the opposite divided by the adjacent. So that would be 1 over the square root of 3, which means you would have to rationalize the denominator, taking it times the square root of 3 over the square root of 3, which would equal square root of 3 over 3. So that's how they come up with that. You don't have to memorize sine 30, cosine of 30, and so on, but what is very important that you do memorize the special triangles, the 30-60 triangle, and also the 45-45-90 triangle, which, if you recall from geometry, since it has two 45-degree angles, it is also an isosceles triangle with two equal sides. So the legs are referred to as having a measures of angles, or measures of 1, and then the hypotenuse has a measure of the square root of 2. So then you get the sine of 45 is the square root of 2 over the whole number 2. Yet again, the reason that you come up with that is because the formula would give us 1 over the square root of 2, but rationalizing the denominator would give us that square root of 2 over the whole number 2. Then you can see what the cosine of 45 degree is, and the tangent of 45 is exactly 1 because it would be opposite of 1, which is 1, over adjacent, which is 1, and that equals the whole number 1. So again, don't worry about memorizing sine, cosine, and tangent of those angles. It's more important that you memorize what the triangles look like. So we can use those special triangles to figure out the exact measures of missing sides. Use a trig function to find the value of x, round to the nearest tenth if necessary. So example 3, we're trying to figure out x. In relation to the known angle, the 30-degree angle, right there, x is an adjacent leg. And the known measurement, the 8, is a hypotenuse. So which of our functions uses adjacent and hypotenuse? Well, there's two functions, but the one that is more commonly used would be the cosine. So we set the cosine of 30 equal to the measure of the adjacent leg, which is what we're trying to find, is x, over the hypotenuse, which is 8. From our special triangles, we know that the cosine of 30 degrees is the square root of 3, because that's the adjacent side of our special triangle, and the hypotenuse is 2. So I'm going to replace the cosine of 30 with the square root of 3 over 2, which gives us a ratio that we can solve by cross multiplying. So 2x is going to equal 8 square root of 3. Then we'll divide by 2. We get x equal to 4 square root of 3. And sometimes we can just stop right there, except the directions tell us to round to the nearest tenth. So I will go to a calculator and take 4 times the square root of 3. And when you take 4 times the square root of 3, you get approximately, to the nearest tenth, 6.9.